Alright, we're back. We're talking about 3.11 or 3.11. This section is about what's called linearization. Probably, in my opinion, one of the most unnecessarily difficult topics in Calculus 1. For me, it took me quite a few years, actually, of revisiting it and tutoring it for me to finally understand where this equation was coming from. And when I found out what it was, I felt pretty silly that it had taken me so long. So I just want to share this with you. What's going on here is we're taking some function f of x. It could be any function, as long as it's differentiable. And what we're doing is we're evaluating f of x at some point when x equals a. So when x equals a, that means that we're plugging in a for the x part of the function. Now, if we plug in a to f of x, the output is going to be f of a. So in other words, what that function is when x equals a. And what that's going to give us is that's going to give us a line. If we take the tangent for the slope, that's going to give us a tangent line. And we're going to call that line big L of x. And that's the linearization of f of x. And once I realized it was about lines, I thought, okay, well, I know how to deal with lines. I'm going to use y equals mx plus b. In this case, we're looking at the linearization, though, so I'm going to call it L of x equals mx plus b. And then we ask ourselves, what do we know? Well, we know what m is. M is slope. It's defined as slope. And thanks to calculus, we know of an easier way to find it than rise over run now. We could find the slope by taking f prime of x. And that will give us the slope at any given point on f of x. But we're not interested in just any given point. We're interested in what the slope is when x equals a. So what we're really looking for this specific graph is that the slope at that point when x equals a is the derivative when we plug in a. So it's f prime of a. So we've solved for m already. We still don't know what b is, but we can find that out. So let's plug in m. We've got L of x equals m, which is f prime of a, times x plus b. And we want to solve for b, but we have three unknowns. We don't know what the output is, we don't know what the input is, and we don't know what the point of intersection is. But as we look at it closer, we'll notice if we're evaluating it at x equals a, that means that our x value is a, and we know that the output when x equals a is f of a. So our y, or our L of x at that point is going to be f of a. So we fill in what we know. We know that f of a equals f prime of a, and x is a right now, so we'll multiply f prime of a by a plus b. And so now it's just a matter of algebra. We're going to solve for b. We're going to subtract this term over, and we're going to get b equals f of a minus f prime of a times a. So we subtracted this term over. And now we know what b is, so we can fill in the last part of the equation that we don't know. So L of x equals f prime of a times x plus b, which b is f of a, as we solved here, is b is f of a minus f prime of a times a. Alright, then we're going to find some common factors. There's two things that have a factor of f prime of a, one there and one there. So we're going to pull out the f prime of a. And we'll start by writing the f of a, which we're leaving alone here. That's coming over here. Then we've got plus f prime of a, which we pulled out of both this term and this term. That's f prime of a. And we pulled it out of both x and minus a. So we can rewrite this as x minus a. And this is the linearization formula. And that's literally all we've done here, is we've created a point-slope line for some given point a. So now that we've discussed where this comes from, let's look at a specific problem. We'll look at, from 3.11, we're looking at problem number 5. Alright, let's get rid of this. I'll leave the formula down at the bottom. And problem number 5 is going to have us use linearization as a way of approximating a value on the graph f of x. So the equation here is that f of x equals the cubed root of x. Or you could write that as x to the 1/3. Alright, and they're saying that x of 0 is 8.4. So that's the point that we're trying to approximate for. But what it says next is it says find a linearization that will replace the function over the interval that includes the given point x of 0. Center the linearization not at x is 0, but at a nearby integer, x equals a. So we're actually not going to be analyzing at 8.4 for the sake of conveniency and calculation. We are going to choose for the value a to be x of 0's closest integer, which is going to be 8. And so that's the part A of this problem, is because my point was 8.4, so the nearest place we're going to work from is a equals 8. And that's just because it asks us to round to the nearest integer. Alright, so the next part asks for a linearization of this whole thing. So we know what a is, we know what f of x is. We can solve for f prime of x. So f prime of x to the 1/3, using the power rule, we bring down the 1/3, x, and then we minus 1 from 1/3, which is minusing 3/3 from 1/3, which leaves us minus 2/3. And if we want to rewrite this in an easier way to understand, we could write this as 1 over 3 x to the 2/3. Alright, so now that we're at this point, we're going to create our linearization. So L of x equals f of a, which is 8, so f of 8, plus f prime of 8, so that would be 1 over 3 times 8 to the 2/3, and then times x minus a, which is 8. And let me write f of 8 in terms of this. So if we plug in 8 for what our f of x was, we would end up with 8 to the 1/3. Alright, now it's time to plug into the calculator. So 8 to the 3rd root is 2. 8 to the 2/3, 8 squared is 64. The 3rd root of 64 is 4. So this is plus 1 over 3 times 4. And then this is all multiplied by x minus 8. And that's our linearization. Specifically at point A. So I should probably write that down. At point A, this is our linearization at A. Alright, so now that we're at this point, it's just a matter of simplifying. So the 3 times the 4 is a 12, so 2 plus 1 over 12 times x minus 8 equals our linearization for that specific point A. And so this is, you could simplify it further to make it look more like a point slope form, but math labs seem to be happy with this as an answer. So I hope this was helpful, and I'll see you next video.